So we've actually been talking about the periodic table for a little bit, and we've talked about the groups at the top, 1, 2, 3, 4, 5. So 1, 2 on these here, on the first two columns, 3 through 12 in the transition metals, and then 13, 14, 15, 16, 17, 18 on the rest of these groups on the right. So what I want to introduce now is a different way of talking about the group. So this is a different group number system. So we have 1A here, 1B, sorry, nope, not 1B. We have 2B here, no, 2A, excuse me, 2A, and then 3A here, 4A here, 5A here, 6A, 7A, and 8A. Okay, now why do we have this numbering system? Well, it helps explain the charges and the valence electrons, okay? So everything in group 1A has one valence electron, all right? Everything in group 2A has two valence electrons. Everything in group 3A has three valence electrons. 4A has four valence electrons. 5A has five valence electrons. 6A has six valence electrons. 7A has seven valence electrons. And 8A has eight valence electrons. All right? So the atoms in group 1A want to lose one electron, so they will lose one, okay? And they'll become a 1 plus. The atoms in group 2 want to lose two electrons, and they will become a 2 plus charge, okay? The atoms in group 3A will lose three, and they will become a 3 plus charge. Now, if you look at the last group on the far right, group 8A, those are the noble gases. And the noble gases are stable, okay? So let me, again, be patient with me. I'm doing this all with the mouse. These are stable. All right, and they don't want to lose or gain electrons, so they're just gonna be a zero charge. And group 7A, they're one away from being like the noble gases, so they are going to gain one electron. Okay, and they will have a -1 charge. Group 6A will gain two electrons. Okay, so they're going to gain two. Group 5A is going to gain three electrons. Okay, and they'll have a charge of -3. What we're not going to worry about are the transition metals. Okay, don't worry about those. Don't worry about group 4A so much. All right, and don't worry about these metals down here, the lanthanides and the actinides. Don't worry about those too much, okay? So don't worry about these, don't worry about these, and don't worry about these. What we're going to focus on are the representative elements, and they show a more succinct pattern. The pattern's kind of easier to follow because the rest of these, like in chemistry, there's always an exception to the rule. Okay, and these are the huge exceptions. The other ones that I circled follow a better pattern. So the trend we want to see on the next slide, the metals which are in group 1, 2, and 3, they don't have a lot of valence electrons. So they have between 1, 2, and 3 valence electrons, and they will want to lose electrons. Okay, they want to lose electrons. Okay, to match the number of valence electrons of the nearest noble gas. These ions are positively charged. So positive ions form when the number of electrons are less than the number of protons. So right on this summary here, group 1 metals lose 1 electron, group 2 metals lose 2 electrons, group 3A or 13 metals lose 3 electrons. On the other end of the spectrum, nonmetals have 5, 6, or 7 valence electrons, and they will gain electrons to match the number of valence electrons of the nearest noble gas. These are negative ions or anions. Okay, that's when the number of protons are more than, the number of electrons are more than the number of protons. And we can see this in group 7A, group 6A, group 5A.